we have an oscillating mass, a mass which is sitting on a spring. It's suspended by a spring and it is able to oscillate up and down. So you basically take a spring with a mass on it, you pull it down and you release it and it will oscillate. So it will look a bit like this. Notice it goes between two extreme values, the lower point and the upper point. The equilibrium position will be halfway between them. So this is an oscillation. What is the law that describes the behavior of a stretched spring? You know that when you apply weights to a spring and you stretch it, the force will cause an extension in the spring. This is known as Hooke's law. We find that the extension is proportional to the force that's applied to it. So this is Hooke's law. And this is basically what it looks like. If we apply the stretching force, we will get an extension and it will be proportional. In other words, if you double the force, you double the extension. The force is proportional to the extension until it reaches this point where it breaks or gets damaged. This is the Hooke's law limit. You should know about this already. So we know that the force, the stretching force, is equal to a constant times by x is equal to negative kx. I put the negative there because the force that's pulling back on the spring is in the opposite direction to the extension. So the question is, would this exhibit simple harmonic motion? You must remember the equation for simple harmonic motion is at the top. A is equal to minus omega squared x. Is this equivalent to this? Well, you know that F is equal to ma. So we rearrange a little bit. Since we know that A is proportional to X, in this case, because A is proportional to X, this will also be simple harmonic. So this is simple harmonic motion because the A is proportional to the negative X, the displacement. Now, first of all, we need to rearrange this equation to make A the subject. So we divide both sides by m. So we get A is equal to negative k over m times by x. Let's compare that to the equation for simple harmonic motion. What is the difference between this equation and this one here? We see that we have negative sign there, we have a negative sign there. X. The difference is this is omega squared and this is k over m. So, and this is going to exhibit simple harmonic motion. So k over m must be equal to omega squared. Now we know that k over m is equal to omega squared. Let's find the square root of everything. The square root of k over m is equal to omega. We know that omega is equal to 2 pi f, in other words 2 pi divided by t, because f is equal to 1 over t. Let's rearrange this, make t the subject, and we find that the time period of this oscillator will be equal to 2 pi root m over k. So the time period depends on basically two factors only: the size of the mass and the value for k. It doesn't depend on the size of the oscillation. You could start with a very small oscillation. The time period would be the same. Now, what we can do in a lab is to do an experiment where we change the mass, we vary the mass, and see how it affects t. We know that t is proportional to the square root of the mass. So if we draw the appropriate graph, we'll get a straight line graph where the gradient will be equal to 2 pi over root k. And if we know that the gradient is 2 pi over root k and we find the value for the gradient, we can work out what the square root of k is, and therefore we can find out what the value for k is. So we're going to plot a graph. What will the axis be to produce this straight line graph? Well, the y value has to be t, the x value has to be the square root of m, and the gradient will be equal to 2 pi over root k. You have to solve problems using the defining equation for simple harmonic motion. This is the kind of equation that you could get, the kind of problem. You have a wooden block which is oscillating in the water, and it is exhibiting simple harmonic motion. We know that for simple harmonic motion, A is equal to minus omega squared x. And the question is this exhibiting simple harmonic motion? Is there a negative sign there? Yes. Is it proportional to x? Yes. So this is going to be simple harmonic. Told that this is an equation where rho is the density, g is the value for gravity, the gravitational constant, sigma is 8.4 times 10 to the 2, which is a constant there, and L is the length of the wood. Basically, I have to find a period of oscillation and find the maximum acceleration.